Now let's turn our attention to example number 6. We're still going to be dealing with limits where x is approaching infinity, but you'll see that we no longer just have a polynomial divided by another polynomial. And the reason for that is the introduction of these square root symbols. Now, in this question, we're going to be trying to take the same basic approach that we did in the previous ones, finding a special red amount to multiply by. And again, the reason for this is that if I was to take a look at what's happening in the numerator and the denominator of this fraction, I can see where things are going to be headed, and they're not headed to a good spot. If x is moving towards infinity, my denominator is going to become infinitely large. But also, my numerator is going to become infinitely large. As you'll notice, the inside of the square root is still going to have a super large value when x is squared, multiplied by 2 is even bigger, and then plus 1. The square root makes it a little bit smaller, but as the value of x continues to grow, the numerator will continue to grow in size. And again, whenever I get something like infinity over infinity, that's not a value that I can actually work with, right? Because that's not a well-defined mathematical value. So I'm going to have to go ahead and tackle this in a slightly different way. Like we did in the last video, I'm going to try to find something to multiply by. So here's what I'm going to go ahead and do. I'm going to go ahead and see if I can use the exact same strategy that we did on the previous example, which is I'm going to go ahead and try to multiply by 1 over the largest power of x that I see in the denominator of the fraction. So in this case, that would still be x to the first power. Now, when I do this, I can see that some things will get nicer and, well, other things won't. Notice that in the bottom of the fraction, if I distribute and simplify right away, I'm going to get 3 minus 5 over x. However, in the numerator, things get really ugly. Look at this. 2x squared plus 1, and then all of that square root now has to be divided by x. So I'm going to put this in a set of parentheses just to make it more visually appealing. Okay, so I have this limit now, and you might be thinking, okay, great, Kyle, like I can compute what's happening in the denominator now, right? Like this is going to turn into 3 minus, and this part should be turning into 0. So the bottom is just 3. But what the heck do I do with this thing? Because I'll notice now that this thing still has the same problem that we started with. The top of it's going to infinity, and the bottom's going to infinity. So I haven't really fixed many issues here. But this is where we're going to have to go ahead and pause the argument to try to explain something. And I'm going to ask you to do a very similar explanation when I let you try part B in just a moment. So make sure you pay attention to this. Here's what we're going to go ahead and note. First, I want to just make note that x here is moving towards positive infinity. And so, if it's moving towards positive infinity, then the values that I'm imagining x take on are going to be very large positive numbers. So, we can assume that the x's that we're working with are going to be greater than 0. And this is going to allow us to say something really important. Our goal right now is actually going to be to highlight a very important algebraic fact that sometimes we may have forgotten about. All right, let's pause what we have right here. And I'm going to highlight a new algebraic fact, and we'll talk about how it ties into what we have here. Okay, here's the algebraic fact that I want to go ahead and talk about. We'll put it up here in this little box in the corner. I have a question. What is the square root of x squared? That's the question. It's a simple algebraic question. It's the only thing I'm interested in right now. What is the square root of x squared equal to? All right, do you have an answer? You may have said it out loud or thought it in your head. But here's the big surprising part. Most people answer x. And if you did, I hate to tell you, but you're wrong. The square root of x squared is not x. And if this is blowing your mind partially right now, and you're starting to think, oh my gosh, I know nothing about nothing about algebra. Apparently everything I know is wrong. How is this possible? How could the square root of x squared not be x? Don't the square root and the square just cancel out? Well, No, they do not. And a long time ago, someone actually probably informed you of this fact in a previous algebra class. However, um, due to some reasons that are only speculative on my part, they decided to stop telling you that. And they made things a little bit too easy for you at times. Let's talk a little bit about why I can state confidently that these two things are not equal. Well, for example, let's quickly go ahead and take a look at what would happen if x was equal to, say, the number -2. If x was equal to the number -2, then notice I would have -2 squared underneath the square root, and it should be equal to -2. Now, when I take -2 and I square it, I end up with the value of 4. And then I have to square root that value. The square root of 4 is just the number 2. Remember that square roots only actually spit out positive answers. That's why the square root function looks like this. You can only get positive outputs, only positive y's. But here, then I would end up with a statement that says 2 is equal to -2. And that is most certainly not true. And so if this is not true, this cannot be true. Now, if I was instead going to change this to the value of +2, then everything will actually work out just fine, because then I will get 2 is equal to 2, and everything here will be fantastic. So I just have to be a little bit careful here about what exactly it is that we're attempting to say. I have to note here that this is a statement that doesn't work all the time. It only works, some of the time. So I have to actually go ahead and figure out, is there a way that I can actually go ahead and make this, change that to this. Is there a way that I can actually make this into a statement where these things would be equal? And the way that I can do this is to actually just put absolute value bars around what I have over here. Because now notice when I plug in a negative number on the in for x, this output over here is always going to be the same. Now, if it's the case that x is positive, then of course I know that these absolute value bars don't do anything and can be dropped. Let's take a look now back at our question to see how this is relevant. Note here that since x was going towards positive infinity, we were able to assume that x was positive. And so we can state confidently that x is the same as the square root of x squared, because x is positive. If x is negative, then this would have to be true. But since x is positive, we don't have any risk, and now this will work. So what that gives us then is the following. We could now go ahead and replace that value of x that's occurring up here with the square root of x squared. And this will allow us to continue to enact more algebra moves. I'm not going to touch anything with this denominator right now. It's actually in a great spot. I really like that. But up top, you'll notice I have a square root divided by another square root. And I'm going to combine those into a single square root. Now that this is divided into a single square root, I'm going to go ahead and notice that if I did the limit of the square root in the top, I could really just do the limit of the inside. But notice I still have a problem, because the limit of the inside still has infinity and infinity. I still have this same exact issue of having this positive and positive infinity occurring on top and on bottom. So what I'm going to go ahead and do is one final algebraic move, which is going to actually be to split this fraction into two fractions, 2x squared over x squared plus 1 over x squared. Now I can simplify this down a little bit before I write out my final result. In the numerator, I'm going to have a square root of 2 plus 1 over x squared, and then 3 minus 5 over x. Now notice when I actually compute this, I'm going to get 2 plus 0 in the numerator and 3 minus 0 in the denominator, leaving me with the final result of square root of 2 over 3. That is a lot of work. If that feels like, wow, there was a lot going on there, you're absolutely right. You might need to go back and re-watch some of this to make this idea clear. And to help actually try to solidify this idea, I'm going to ask you to start working through part B. Notice here, one thing is going to change, and that we're going to be moving towards negative infinity, but otherwise the function is the same. So I'm going to ask you to see if you can start to try to work through that example, and you can start with the same basic steps. So go ahead, pause the video, see if you can go ahead and try to work through this, and then of course when you unpause, you'll see me work through the solution. Okay, well hopefully you spent some time working through that solution there. Let's see what we come up with here. So the first step that I can do here is multiply by a 1 over x on top and bottom. And if I do this, I'm going to end up with a limit as x approaches negative infinity. I'm still going to have this 2x squared plus 1 over x and my 3 minus 5 over x. And now I'm going to need to make my note. This time I can say that note that since x is going towards negative infinity, we can assume here that x is actually going to be, that should say, less than 0, right? Because if I'm moving towards negative infinity, x would have to be in the negatives. It's got to be some negative number. And so I can go ahead and actually state that, or at least know, that x equaling square root of x squared is not actually going to be correct, right? Because we already saw this when we looked at the example of here when x was a negative 2. It's supposed to be that x is that I have absolute value of x over here. But if I don't want to do absolute value of x, couldn't I instead, if I know x is negative, simply multiply this by a negative? That's going to, if x is negative, have the same effect as the absolute value bars. It'll take the negative x value, multiply it by a negative to turn it positive. Now, of course, I don't have a negative x value here to replace, so of course then there would be no issue coming here and getting rid of this negative sign and changing this over here to be negative, right? Just kind of like multiplying both sides by a negative 1. So now what I can do is I can state that this is a limit as x approaches negative infinity, and I'm going to have square root of 2x squared plus 1. I'm going to have a negative square root of x squared, still divided by 3 minus 5 over x. Then I'll go ahead and I'll kind of combine a couple steps here. I'm going to go ahead and simplify everything into a single square root and separate out the fractions. And then if I go ahead and I evaluate the limit, notice I'm going to get a negative square root 2 plus 0 over 3 minus 0, and end up with negative square root 2 over 3. Remember, this negative here is just coming from this negative, which is what I need to compensate for the fact that x is a negative value here. Now, sentences like these need to be written. They have to be there because I have to explain what I'm doing. And so remember that if you were doing something like this in a homework assignment or on an exam, you would need to write sentences to explain to me what are you doing. If you just make substitutions, it's not clear what's happening. Now what you'll notice in both these questions that we've again evaluated a limit in two different directions for a specific function. And so we could ask, what do these two parts really tell us is going to be happening with the function of this square root of 2x squared plus 1 over 3x minus 5? Well, what we can see is if I had a function square root of 2x plus 1 over 3x minus 5 has horizontal asymptotes of y equals square root of 2 over 3 and also y equals negative square root 2 over 3. Again, we're finding information about horizontal asymptotes by computing these limits.